Hello, I welcome you all to this another interesting screencast. We're going to be solving this engineering mechanics problem, and it reads: determine the force in each member of the space truss and state if the members are in tension or compression. The truss is supported by rollers at A and B as well as C. Right. This problem is coming from the engineering mechanics, the mechanics statics textbook, 13th edition by R.C. Benam. So we have a space truss, and let's examine, okay, the geometry and the loading for this space truss. So we've been told all the supports at A, B, C are rollers, and therefore when we look at the direction of the loading, we expect only vertical reactions in the Z direction, and they will all be pointing up like that. Okay, so these are the reactions that we expect. This is BZ, CZ, and AZ. And then the geometry of this particular truss space truss is symmetrical about this plane. I'm just indicating the plane right now in red, about the YZ plane. Okay, so there is symmetry about the Y Z plane. Okay, so because there is symmetry in the geometry of the space truss, and also the loading is symmetrical. If you've seen, the loading also is symmetrical. This makes the problem much easier. So it means because of symmetry, we know that the force the member force in AC, the member force in AB is going to be equal to CB, right? And the member force in AD is going to be equal to CD, right? The only ones that will have individual member forces is AC as well as BD, right? How many? 1, 2, 3, 4, 5, 6. For of course the members are 6. So we have a pair of members, two members, each having equal forces or equal forces in their members, and that's AB. AB is equal to BC, and AD. Where is AD? AD is equal to CD, and then AC will have its own force member as well as BD. So because of this symmetry, both geometrically as well as the loading, we are only going to work on few joints, okay, for us to find the member forces. And for this particular problem, we can either use vector, okay, analysis, or scalar. So I'm just going to use the scalar for this particular problem. So I'll use joint D. I'm going to work on joint D using the joint method, joint D. And then I'll also work on joint A as well as joint A, joint D. Joint D will give me this. Joint A is going to give me this and this, and that's it, right? That's it. Joint D and joint A are enough. I'll have everything, because when I find a member force in AB, I'll have found CB. So only two joints. I'll just work on two joints, only two joints. A, D, and A. So what I will do is I'll indicate the slopes. Okay. Remember the unit vectors? We can write them just as slopes like we normally do in 2D. When we have a right angled triangle like so. So we know to say when this is 3, This is 4. The 3 squared, that's 9, plus 4 squared, which is 16. 25 root of 25. This gives us that. Okay, this is 2D, but for 3D, we have x, y, and z. So we need to find the slope, like we normally compute unit vectors, and then use that directly to work out the unknowns. We are going to compute equations, apply the equations of equilibrium. All right, so I've already done the drawing for the slopes for each particular member, those that I'm going to be working on. AD, I've done AD, even some of them that I'll not be using to just show you. So I've done the slopes for AD, CD, DB, as well as AB. Okay. All right, so let's go to the next page. There we go. So we have these slopes, okay, already done. So what we just need to do, so we have the slope. This slope here, if you've seen, you have AD, it is the slope for this one here, okay. Then we have this one CD, okay, it's a slope for which is this one, right? And then we have AB as well as BD, okay, so it is this as well as this. All right, so we have these slopes. So what we need to do now, we just need to draw the free body diagram quickly, which we did already in the other case. So we said we have reaction forces here. We have a BZ there. We have AZ, and then there we have CZ. All right, and then let's imagine we are having compressive forces there at that joint. So all the arrows will be pointing up like that, okay, like so. All right, so we have let's say this one is BD, let's say this one is CD, and let's say this one is AD. Okay, then of course we expect the compressive forces also on the other end there. All right, then let's say here we have the tension forces, okay, in these members, in the other members, like so. Okay, so now let's write our equations of it. Right, so now let's start with joint D. Okay, so let's apply the equations of equilibrium. We start with summation of forces in the x direction, like so. What do we have? We have AD. Okay, we're using this one, AD. So AD there in the x direction, it will be negative, so it will be minus AD times the slope, that's 3 times divided by 7, the hypotenuse. Then we go to CD here, okay. CD here, x is going to be positive, so it will be CD 3 divided by 7. Then we go to BD. BD do not have any component in the x because it's in the YZ plane. Therefore, this is just equal to 0. And from here, we know that AD is equal to CD. Then summation of forces in the Y direction equal to 0. What we have? AD. We start with AD. AD, do we have positive? We come here again. The same process, we repeat it for each particular slope. So AD in the y-axis is AD in the y-axis is positive, so this is going to be equal to 2 divided by 7. And then we have a CD in the y direction is positive also, CD 2 divided by 7. And then BD is negative, so it's BD 2.5 divided by 6.5 equal to 0. Then finally, summation of forces in the z direction equal to 0. Alright, I think I can still bring it here. I can still bring it somewhere here. Alright, so what we have AD. All of them are positive, so AD by 6 divided by 7 plus CD by 6 divided by 7 plus BD by 6 divided by 6.5, and then we have a minus 8, like so, equal to 0. So what we're going to do, since we found what CD is, we can replace CD where we have AD, then replace it here, and also can replace it here and also there. Okay, so when we do so and then work out those equations, the first one will give us a 4 over 7 CD minus BD 2.5 minus 2.5 over 6.5 BD equal to 0. The second one will be 12 divided by 7 CD plus BD plus 6 divided by 6.5 BD, and then equal to 8. Okay, we can take 8 outside. So we can make one of these. We can make this. We can say let our CD making its subject formula be equal to, it becomes equal to 7 divided by 4 times 2.5 divided by 6.5 BD. Okay, then we replace this CD here and then make BD subject to the formula. If we did so, our BD is going to be equal to, just grab my calculator. So we have 7 divided by 4 times 2.5 divided by 6.5, and then we have times 12 divided by 7, okay, plus 6 divided by 6.5, okay, and 8 divided by answer. So we have BD equal to 3.85 or 85, let me 19 what are the units for these kilonewtons? Okay, let me just redo it again to just avoid errors. Okay, and then we have 12 divided by 7 plus 6 divided by 6.5 and 8 divided by answer. Alright, 3.8519. Okay, so we have our BD, and therefore our CD is going to be equal to, this 3.851851 goes on, then times 7 divided by 4 times 2.5 divided by 6.5. Okay, so we have a 2.59 226 kilonewtons. Alright, so we found this since Since CD is equal to AD, therefore our AD also is equal to 2.5926 kilonewtons. So we found the three. So we have AD equal to CD. C is equal to 2.5926 kilonewtons, and this one is in compression. And then we have BD, which is equal to 3.8519 kilonewtons. All right, so then let's move on to joint number A. Let's move on to joint number A. I'll need to wrap this. Okay, can I go maybe to the next page? So joint A, what we have, summation of forces in the x direction. On joint A, we've already found what AD was. AD is, and A in the x direction, we expect AD to be positive, so it is AD times 3 divided by 7. 3 divided by 7, and then we have AC. AC is within the x-axis, and we have assumed it to be in tension, so it will be minus. It's going away at joint A, so it's AC. We don't need any slope. And then we have AB. AB, we have this one here. We are going to use this for the slope. It's just in one plane, which is the XY plane. So AB in the x-axis, it will also be negative. It will also be negative, so it will be AB to be negative, so it will be AB by 3 divided by root of 29.25, then close bracket equal to 0. All right. Yeah, I guess that's about it. Okay, so we have one equation. Mind you, AD is already known. Okay, then we have summation of forces in the y direction equal to 0. What do we have in the y? AD in the y, we expect it to be negative, so it will be minus AD by 2 divided by 7. AC in the y is going to be positive, so it will be plus AC no, AC there is no, sorry, AC hasn't got any component. I thought it was AB. AC is just along the x-axis, so this one, it will be AB is positive, right? So it is AB component of AB, so we have AB by 4.5 root 29.29 equal to 0. Then from here we know what AD is. Remember, we found this is the AD. We know what AD is, this value here, so we can just bring it and feed it there, right? And if we do so, then our AB is going to be equal to, if you feed it there, then we're going to say that 2.5926 times 2 divided by 7, okay, and divided by 4.5 divided by root of 29.25. This one is 29.25, not 29. Okay, 29.25. All right, something like that. So what we get is AB is equal to 0.8903 kilonewtons, and it is in the direction that we assumed it, which is tension. Okay, so let me just repeat it. 4.5 divided by root of 29.25. There we go. And then we have 2 divided by 7 divided by that, and then times AD, which is 2.59 to 6, 0.8903. All right, there we go. So we found what AB is. So of course it becomes easier for us to find what AC is. So therefore our AC, since we know what AB is and AD, we can go ahead and find what AC is. So we have 3 divided by root of 29.25. There we go, times AB, which is 0.8903. Okay, this is a negative. Then we have plus 2.5926 times 3 over 7. All right, therefore AC is equal to 0.6173 kilonewton, and is also in tension as we had assumed it. Okay, just want to go through it again so that I make sure I have not made any mistake. 8903 plus 2.5926 times 3 divided by 7. Okay, 617.3. All right, so found AC, we found all of them. So let's go to summation of forces in the Z direction. What do we have? In the Z direction, we have we only have 2 components. We have AZ and then minus AD by 6 divided by 7 equal to 0, and therefore our AZ is going to be equal to our AZ will be equal to AD. What is AD? AD is 2.5926 times 6 divided by 7. Right, so AZ is going to be equal to 2.222, okay, 2 kilonewtons. All right, so we have found AZ from this, and let's write now what we have. So we have AB. Where is AB? AB, we said AB is equal to CB, which is equal to AB and CB. These ones are equal, and we found this to be equal to 0.8903 kilonewtons, and this is in tension. Okay, and then we also found what AC is. AC is standing alone, AC standing alone. AC is equal to what's AC? Said AC is equal to 0.6173 kilonewtons and is in tension. And we found what AZ is. Of course, were we asked to find AZ? No? Okay, we just found it anyway. It's 2.22 kilonewtons. All right. I guess we can find also what BZ, and this is symmetrical. We expect AZ to be equal to CZ, okay, which I can just call, let's say, let me call it just FZ, okay, so 2FZ, if I was to do summation of forces in the Y, summation of forces in the Z equal to 0, so I would say 2FZ, all right, because there are the two of them, plus BZ minus 8 is equal to 0. Okay, since we found what AZ is, we said this is equal to 2.2222 kilonewtons. So then we just say 2 times 2.2222 plus BZ minus 8 equal to 0. Therefore, our BZ will be equal to, what is our BZ equal to? So we have 2 times 2.22 minus 8. So we have BZ is equal to 3.5556 kilonewtons. All right. So we have CZ equal to also 2.2222 kilonewtons, and then we have BZ equal to 3.5556 kilonewtons. All right. So let me work out a summary of the solution. We have AD equal to CD equal to 2.59 kilonewtons and is in compression. Then we have BD, okay. Then we have AB equal to CB equal to 0.89 kilonewtons and this is in tension. All right, and then we have BD equal to 3.85 kilonewtons, okay, and this one is in compression. And then we have AC equal to 0.62 kilonewtons and this one is in tension. Then we have AZ, which is equal to CZ, which is equal to just a 2.22 kilonewtons. Then we have BZ, which is equal to 3.56 kilonewtons. Right. I guess we are done, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my videos. Bye bye, and I'll see you in my next screencast.